Lab 1 charge tape. So, the purpose of this lab is to prepare pieces of clear tape and observe the interactions between those pieces of tape. We will then approximate how much excess charge is on one piece of the charge tape. Some goals of this lab is to observe the interactions between the tape, determine the excess charge on one piece of the charge tape, and simulate those interactions in GlowScript. Some of the assumptions we can have going into this lab is that the tape can be modeled as a singular point charge, we can ignore air resistance, and that both tapes have the same amount of point charge. And to summarize the results, we've known that the charge clear tape has a positive net charge of 1.4 times 10 to the negative 8 coulombs. So going into the key concepts from this lab, one of the first concepts is Newton's second law, which states that the net force is equal to the change in momentum over the change in time. And then the velocity update formula relates the velocity of object to its net force. Another key concept is gravity, specifically gravity near the surface of this Earth, which explains that the force of gravity near Earth's surface is the mass of the object times gravity, which is negative 9.81 meters per second squared. The last key concept, and possibly the most important concept for this lab, is the electric force Coulomb's law, which states that the electric force equals Coulomb's constant times the product of the two charges divided by the square of the distance between the charges. Now, going into the procedure of the lab, what we start with is creating a base tape with two U tapes. Then, in order to charge a tape, we in order to charge the U tape, we pull up the U tape from the base tape. We then observe the relationship between the two U tapes. Now, when we observe now after that, we observe the relationship between the two U tapes and the charged plastic objects. The plastic object that we used was a plastic pen that was rubbed on somebody's hair. We then place the U-tapes above one another and observe the motion of the top U-tape versus the bottom and calculate the separation distance between the two tapes. Moving on to the observations from the lab, we learned the two U-tapes repelled each other and that the U-tapes in someone's hands were attracted, and that the U-tape and the charged plastic object were attracted. From these observations, we can assume that the pen was negatively charged due to it being rubbed on clothing, and then therefore the U-tape was positively charged. The suspended U-tape and the U-tape below repelled one another, and the separation distance was 0.03 meters. When looking at the free body diagram, you can see that the force of gravity is pointing down on the suspended U-tape, that the electric force is pointing up from the held U-tape, and that the systems in this experiment are the suspended U-tape and the surroundings would be the held U-tape and Earth. Now, when looking at our data, we can see that the tape length is 0.02 meters, while the width is 0.02 meters. The tape mass is 2 times 10 to the 4 kilograms, and the tape weight is 0.00196 newtons. Now, using Coulomb's law, we can figure out that the charge of the tape is 1.4 times 10 to the negative 8 coulombs. Now, putting this all into the computational model, you can see with these GlowScript code that the resultant from the computational model looks similar to the free body diagram given. Now, moving on to the discussion, we can assume that for the suspended tape to float, the force must be equal, which means that the suspended tape and the tape held were in static equilibrium, meaning that the force of gravity equals the electric force repelling this suspended tape in order to hold the suspended U-tape. Now, some possible sources of error that can come from this equation would be measuring the tape lengths, widths, and separation distance, two tapes possibly not being parallel, and then incorrect rounding in our calculations. Now, one discussion question we want to talk about is why is it important to handle the charge tape as little as possible? And we can know that the charges can be transferred between certain objects via contact. So when you continuously touch these tapes, you can make them lose their charge, which is why it's important to not touch them as much.